So in this question, an aircraft travels from A to D, but it was intended to fly to E. It's 1 degree out, and that means the distance that we're trying to find is DE. And this question needs us to understand about similar triangles. So let's look at the two triangles that are involved here. First, there is the yellow one that we have outlined. And then there is also a smaller triangle in the front. So let's just separate that so we can see it. So I'll just draw the outline of the smaller triangle that is within the bigger triangle. And this means because it is within this triangle, the sides are in proportion and the angles are the same. We're going to use the fact that these are similar triangles to compare one length, let's say the base of the smaller triangle, to the base of the bigger triangle. And the bigger triangle would be 60 plus 150 equals 210. And what we want to do is we want to find the scale factor. What do we need to multiply this side by? Because this is the one that is similar to DE that we're trying to find. But the relationship between the base and the longer side of the bigger triangle will be the same scale factor. So the small triangle has a base of 60, and this goes to 210. And this is the same scale factor that's times by something that we want to find out, because we have 1 mile would be times by the same thing that would give us DE. So if we can find this scale factor that 60 is multiplied by, we can use this to find DE. So to do this, we need to find out how many 60s go into 210. That will tell us what the 60 was multiplied by, and that was 3.5. That means if we multiply the mile by 3.5, we get DE is 3.5. The second part of the question says, how should the aircraft have turned towards D when it was at C? So it's off course, remember, but then the question is about going to D. So we have to figure out, what would it have to turn? This is the angle. What would that be for it to get back on target? So this time, to work out whether that angle should be 1 degree or 2 degree or something else, we're going to use parallel lines. So we can see we've got parallel lines. Now we're going to use the angle information to help us. So if you look at the 1 degree here, we can look at the angle up here. We see that these two angles are the same. So if we look at this angle down here, that is part of this triangle here, we could move this triangle up and we would create the same triangle up here, and this angle would be the same. So in other words, if the plane turned this angle here, we would end up at this point. So if we turned 1 degree, it would only manage to get to the X. We want to go down to D, so it has to turn a little bit more. And the question is, how much more? So we're going to use another angle rule here. If we look at the angle here, we can see this angle must be less than the angle over here, because this base is so much longer. And then using the angles in the parallel lines, we can see this angle here, because they're alternate angles, is the same as the other blue one. And now we must know that this angle here, the amount that it must turn, has to be 1 degree here and something that is less than 1 degree. In other words, it has to be bigger than 1 degree, but a bit less than 2 from the diagram. And so we would tick this one.